Hello guys and welcome back to our YouTube channel. So in this video we are going to go through the Northwest Regional Mock question 2. So a metal wire is illuminated by light of wavelength that, and the metal has a work function of that and a threshold wavelength of 497 nanometers. The work function is 2.5 electron volt. That's how you read it. Now they are saying that the Roman one, we should define the underlying phrases, that is on work function and threshold wavelength. Then calculate the maximum kinetic energy of the emitted photoelectron. Then the step by determine the stopping potential of the metal. So let us go ahead and just do it. Now we are starting with the first part, that is we should do what? We should define the underlying phrases, the underlying us work function. Work function. Now work function, it is this minimum amount of energy required to remove an electron. So minimum amount of energy in bracket. Let me just put, so you just write the minimum amount of energy required to remove an electron. I'll just put very, very, very small. This one is just for mine. Then now the second part, we have to define the threshold wavelength. Which means, what is now the threshold wavelength? Well, if you have taken the course of photoelectric effect or on this topic, you know that energy is directly proportional to frequency of the light source of the incident radiation. Now, we are saying that energy is equals to a certain constant multiplied by frequency, removing the proportionality symbol. We are having HF. And you again see that if this now is frequency, we know we are talking about light. Light source has a speed and wavelength, since light is a wave. So we know that the speed of light have to be equal to the frequency of that light source multiplied by its wavelength in any point in time, since speed is a constant. So these things have to be inversely proportional to each other, so that each time they increase and satisfy this equation. And the speed of light is 3.0 times 10 to the 8 meters per second. So each time you have a light wave, maybe any type of light source, the frequency and the wavelength have to give you speed of light. So now the frequency, from here I can solve for the frequency or the wavelength. The wavelength will simply be the speed on the frequency. Is it clear? Now if you are talking about the threshold wavelength, always denoted as lambda 0, have to be equal to C on the threshold frequency lambda f0, right? And the threshold frequency now is the minimum amount of frequency, is the minimum frequency required to liberate an electron. The frequency, right? Now the work function W is always equals to what? H times the minimum frequency. Are we there? Now work function in terms of the maximum or step of the threshold wavelength, you see work function will be C on lambda naught. I've just make the subject here. Now if you substitute here, you get C H on lambda naught, and lambda naught will now be equals to H C on W. And since W is very, very, very small, or the smallest amount, this is a constant, H is a constant with a value of 6.62 times 10 to the negative 34 joule second. It is joule second because frequency is in per second. The joule and the second that this one is having will come, the second will cancel with the second here, will be left with joule for this equation to be homogeneous, since energy is in joule. That is that. Then now lambda naught is HC on. If this is the smallest, you are dividing a constant value with the smallest value you have, then that fraction has to be the at its maximum, right? So lambda naught, now the definition of frequency, it is the maximum wavelength. It is the maximum wavelength required to liberate an electron, while phrase f naught, frequency, the minimum frequency required to liberate an electron, the threshold frequency, it is minimum, while lambda naught, it is maximum. You see from here that f naught is directly proportional to 1 on lambda naught, or inversely proportional to lambda naught, since C is a constant, right? So if we are talking about the maximum frequency, we are talking about the minimum wavelength. If we are talking about the minimum wavelength, we are talking about the maximum frequency. So try and understand that. Now let us go and calculate our thing. We are saying that the energy supply, we have been given the work function to be 2.5 electron volt. We have been given our source wavelength, which is 3.5 times 10 to the negative 5 centimeters, and we have been given our lambda naught, that is the maximum wavelength, to be what? 497 nanometers. So now they are saying that we should calculate what? Calculate the maximum kinetic energy of the emitted photoelectron. So you see that, you know that if the energy supplied to that metal is equal to its work function, the electron will be liberated. But if the energy is more than now the work function, the electron will accelerate. So the energy now to accelerate for this equation to be correct, we now have to see that law of conservation of energy. Energy can neither be created nor destroyed. So it have to be plus another energy that will be used to live with the electrons that the electron will go with. And the energy is what we call the kinetic energy. Any moving body has a kinetic energy. And now you see that the kinetic energy, E minus the work function, have to be equal to the kinetic energy. Or the kinetic energy have to be equal to the energy supplied minus the work function, and the energy supplied is hf minus work function, which is also hf naught. F naught is the minimum frequency required, while f is the frequency that the light source was incident at. Now you see that they have not given us the frequency, they have given us the wavelength. These are wavelength that they have given us. So you can say hf, not more f, you put h into c on lambda, that is f is c on lambda, minus f naught will be h c on lambda naught, right? You now just substitute these values here, we substitute it here, and now we are now having hc on lambda. We have the h to be 6.62 times 10 to the negative 34 joule second, in bracket, I put the next value, 3.0 times 10 to the 8 meters per second. All that I'm dividing by the wavelength, which is 3.5 times 10 to the negative 5 centimeters. All that I'm subtracting from h, which is, I can use this hc on lambda naught. Since I'm giving lambda naught, I know c, which is 3.0 times 10 to the 8. I know h as a constant, but they have just helped me and given me all this value as the work function to be 2.5 electron volt. So I'll just put minus 2.5 electron volt. Now you come, before you apply your before you go to your calculator, is this equation homogeneous? Before you subtract them, here we are having seconds. Seconds goes with seconds. Here we are having meters. Here we are having centimeters. It does not cancel. We are saying this to be a joule. So we have to convert these centimeters to meters. So you know that 100 centimeters makes 1 meter. I'm putting it like this because I want the centimeter to cancel. So if the centimeter, for it to cancel, I have to divide by centimeter on the bottom, then meter should be at top. So centimeter here, meters here, so that this centimeter will not cancel with these centimeters. Similarly, I'll go now to my work function. For it to be homogeneous again, I'll convert this to joule before I'll subtract the two. They must have the same unit. I cannot subtract electron volt from joule. Not possible in physics. So you now put 2.5 electron volt. Now I'll convert this. I know that electron volt have to be on the bottom, then joule have to be on top. Now the conversion is simply 1 electron volt is 1.6 times 10 to the negative 19 joule. Right, you see now electron volt will be cancelling with electron volt. We are left with joule. And here you see that these meters will cancel with these meters. These seconds will go with these seconds. And the joule will be left here and joule will be left here. We can go ahead and substitute and subtract from the two values and get our value for our kinetic energy. Right, so let us take our calculator. Anyway, please, you pray for my dad. This is the pen that my dad gave me. I have a box of it that I'm using since I don't know how old I've been using these pens. So they are still there. Okay, now let us take our calculator. Our calculator now will make sure you see the second function, this button. You hit the second function, you hit the tab or the FE, you press it and then touch the decimal point. Make sure you have done that before you punch values for your calculator not to be rounding. So now we go ahead and we say 6.62 exponent 34, the negative of it, multiplying by 3.0 exponent 8. I got that value, dividing by 3.5 exponent 5. I'll just go ahead and put exponent 7 negative, because 10 squared that here would be 100 is 10 squared, and 10 squared is 10 to the 2. If I take it up here, it will be 10 to the negative 2. Then I join the powers, 10 to the 5 and 10 to the negative, to give me 10 to the negative 7 indices, right? So I punch this value, I got 5.67428 times 10 to the negative 19 joule. This is not your final answer. Avoid rounding up at this stage, else you will be far from the required range of answers. So we now move to the other one. We'll be having 2.5 exponent nothing. So 2.5 times 2.5 times 1.6 exponent 19 negative gives me 4 times 10 to the negative 19 joules. Now I'll put negative of this value, negative of it plus, or let me start it back. So we'll be having 5.67428 exponent 19 negative minus 4 exponent 19 negative, which gives me 1.67428 times 10 to the negative 19 joule. This is now my kinetic energy. Is it difficult? Question mark, please. We wish you the best as you are going for your exams. Okay, now we are now saying that this is our value for our kinetic energy. Now they are telling you that determine the maximum stopping potential of the metal. Well, if this metal is being liberated, it is now moving with this kinetic energy. The stopping potential will be now what voltage should I put on these electrons that are coming with this speed to block them from coming? That is what stop them from coming. Is it clear? Now the PD that you will send against it, right? So now we know that when we talk about work, so you know that work done or voltage is simply by definition work done per unit charge. But now we want to equate something in terms of energy. Then we need energy to equate with energy. So I can cross multiply here. Voltage Q have to be equal to work done or energy. Work done is another term used for energy. So VQ have to be equal to work done. And now let me share it. And now our VQ, we need a VQ that will apply, that will be equal to our KE. Our energy now is our KE, that is the work done now is our KE. To stop the electrons from coming, we need to apply VQ. And here we are talking about the charge of an electron. So V will be equals to E, or E, where E is the charge of electron. VE have to be equals to KE. In other words, I'm looking for V. V now will be KE all on E, right? The kinetic energy divided by the charge of an electron will give me the stopping potential. And now you just see here again, V equals to work done on charge, joule per coulomb, makes you 1 volt. That's the meaning. 1 volt is equals to 1 joule per coulomb, the unit for charge. Now we know that V now will be equal to, we have our kinetic energy down here, 1.67428 times 10 to the negative 19 joule. All that divided by the charge of an electron, which is 1.6 times 10 to the negative 19 joule. Right? So now let us go ahead and solve these values. So we now have 1.67428 exponent 19 negative dividing by 1.6 exponent 19 negative gives me 1.046. V equals 1.046 volt. That is the stopping potential that I need to stop those electrons. So that is the stopping potential. So we have just simply applied it correctly. The values I'm seeing, they mix us from, maybe at least you have gotten the concept. The values, it means maybe when we're taking the data, is it a Planck constant that I've not taken it to be accurate? Is it a wavelength 3.5? Is it 2.5 electron volt? Yes, everything is correct from the question. So this is how you can do a question on photoelectric effect. Thanks you very much for watching this video. I would like you to share this video to your friends. I would like you to subscribe to this channel if you find this channel helpful. If you think you can support this channel to grow, here's our numbers. You can support us no matter what. Anything that you send will be appreciated. You need white sheet and so on and so forth. So thanks you for watching again. Make sure you have a good calculator and you start very well. This is my pens that my dad gave me that I'm using to make videos for you. Means I love you. Okay, have a nice day. Thanks for watching.